Hey guys, we're going to do notes today over piecewise functions, day 2, which is just going to kind of talk about some of the discontinuity that you might see in a piecewise function. So we call a graph continuous if the function has a single unbroken curve. And what I mean by that is like when you have your graph, you basically go forever without stopping. You don't ever lift your pencil to finish the graph. We have 3 types of discontinuity that we're going to talk about. The first one is removable discontinuity. So if you have a graph where you might have a hole in there, that's a removable discontinuity. So the absence of that little piece right there causes you you have to lift your pencil to finish the graph. A jump discontinuity would look something like this, where you have a portion of a graph like right here, and then you finish it this way. So you had to jump in order to finish that graph. And then an infinite discontinuity is when you have a vertical asymptote that interrupts the graph. So like especially when we had those rational functions where you might have something that looks like this and then something down here like this. We're going to infinity on either side of that asymptote right there. So that's infinite discontinuity. All right, let's do some examples of that. Okay, so on this first example, we have 2 graphs to graph for this piecewise function. We're going to graph this linear function, y equals x plus 2. And so I only want to graph those for the x's that are less than or equal to 0. So I don't want anything past 0, so I'm just going to ignore those in my table over here. I'm going to plug in these x values, -2, -1, and 0, just to get some ideas. When I plug in -2 into that equation, I get 0. When I plug in -1, I get 1. And when I plug in 0, I get 2. So if I graph those, I'm going to graph -2, 0 right here, -1, 1, and 0, 2. And then that's just a line. Let's just see if I can draw that line. There we go. So that's a line going that way. Okay. And then one thing to notice is that was less than or equal to, so that should be a solid circle right there. All right, now then we're going to graph the y equals 1 over x, which is a rational function, but we're going to just do it for the x's greater than 0. So I'm just going to ignore these right here. This is undefined right here. That's an asymptote at x equals 0 for that graph. When I plug in 1, I get 1, and when I plug in 2, I get 1/2. And so if you recall, that graph looks, I'm going to plot those couple of points right there. That graph looks something like this. And so we have an infinite discontinuity there because of that asymptote. And we would want to say that we have it at x equals 0. All right, let's do another graph. Okay, on this next graph, we're going to graph this linear graph, -x plus 2. We're going to do it for all the x's less than or equal to 3, but we're going to exclude the -1 when x is -1. So I only want to see the parts that are less than or equal to -3, which is excluding those. If I plug in 0, I get 2. If I plug in 1, I get 1. If I plug in 2, I get 0. If I plug in 3, I get -1. So let's graph those points. And it's equal to at that 3, so that's going to be a closed circle at 3, -1. So I have a closed circle right here. At 2, 0, I have a point. At 1, 1. At 0, 2. Okay, so it's, and then I'm going to keep on going. The only thing is at -1, which it would normally be 4 whenever x is -1, I'm going to have an open circle right there. And then I'm going to keep, it goes forever for all the x's less than -3. Or, I'm sorry, less than 3. So it should look something like that. But we do have a removable discontinuity right there. Okay, and then we've got to finish our graph. For the next one, we have a horizontal line, y equals 5, for all the x's greater than 3. But it's not at 3, it's going to be an open circle. So right here, we have an open circle, and then it's all the x's to the right of that. So we have 2 discontinuities here. We have a removable discontinuity. I can't say that word very well, sorry. and that's going to be at x equals -1, and then we have a jump discontinuity at x equals 3. All right, now let's go to the next page. Okay, on this page they're asking us to write the piecewise functions. So you technically have 1, 2, 3, 4 different things that you're going to be writing on here. They come from this a linear function, they come from this quadratic, they come from this that looks like a cubic function, and they also come from that one little dot right there. So we're going to end up taking care of all 4 of those when we write it. So I'm going to start with I always start from the left to the right is how I do it. So we're going to start with this first one where it's a linear graph. You can see right here you have a slope of a -1 because I'm going down 1 and over 1 each time. And then my y-intercept, if I keep doing that, I should see that my y-intercept would end up being -5 if I were to finish that graph. So that equation would be -x to account for that -1 slope. And then my y-intercept would be a -5 if I finish the graph. So the only thing is I only want to graph the x's from this -5 right here to this -2. Only that little domain will be used for that particular function. So we're going to say our x's should be between -5 and -2. Now I need to think about where it's actually equal and where it's an open circle. And it's only equal at the -5. It's an open circle at -2, so I'm going to keep that just less than there. All right, so that takes care of the first one. I'm going to erase some of that. We've done this one. Now I'm going to now take care of this little dot right here. When x is -2, the y value is -6, so I'm just going to put -6 here, and I'm going to say that's when x is -2. So that takes care of that one. So we can erase that now. Now let's take care of the quadratic function. It's been flipped, so that's going to be a -x squared. And then you've also shifted it up 1, so there's a +1 there to take care of that vertex up there. And then we're graphing it from x is -2 to x is +2, and it has open circles on either end of that. So we're going to leave it just like that. All right, and then this last one is going to be the cubic function that we have over here. If you'll notice, we went to the right 3. We went right 3 and we went up 2 to get that inflection point right there. So I need to show that when I write the equation. I went to the right 3, so x minus 3, and that's a cubic function, so it's x cubed. And then I went up 2, so I'm going to have +2 right there. And then I'm graphing that from x being +2 to 4. It's going to equal, oh, I forgot the symbol, sorry. It's going to equal at the 4, but it's not going to equal at the negative. That's a +2, my goodness. Sorry about that. So at +2, it's x is between +2 and +4. It's going to equal on the 4, but be an open circle on the 2. And that's all 4 of those graphs. Now then we need to find the following values. So we're going to look where we're going to do where x is -4. It's asking what's the y value when x is -4. So x is -4 right here. The y value right there is -1. So my answer there would be -1. Now I could get that from the graph, but I could also get it from my equations. The equation I'm going to use when x is -4 would be this one, because x is in that range for that equation. So I would plug in -4 minus 5, and I would get that -1. So I could do it algebraically or I could do it graphically. All right, on the next one, we're going to do f of 2. F of 2 is, where x is 2, whoops, is right here. But if you'll notice, we don't have any part of the graph actually graphed there. So when that happens, we just say that's undefined. There's nothing there. Okay, and then f of 0, I can see right here when x is 0, the y value is 1. If I were to do it algebraically or using the equations, I'm going to go where x is actually going to be equal to 0. And x is 0 on this equation because the x's here are between -2 and 2. So I would plug in a negative 0 squared plus 1, which would just give me 1. All right, I need to move that down. That last one right there is f of 3. And so f of 3, let me erase some of this over here. F of 3, when x is 3, we're looking at that y value right there, so we would just say that's 2. If I were going to choose an equation to plug it into when x is 3, that's going to be this equation. So we would say 2 minus 3 cubed plus 2, and we would end up getting that value of, or I'm sorry, I plugged in the wrong number. My bad. So plug in 3, I'm sorry, so 3 minus 3 cubed plus 2. So that gives me 0 cubed, which is 0, plus 2, which gives me that 2 value that we found graphically as well. All right, let's answer some of these questions that we have below. Okay, this is going to be kind of hard to look at these questions and the graph, but I'll try my best. So the first question says, what are the x-intercepts of this function? Well, the x-intercepts are here, here, and here. So you have x-intercepts at negative 5, 0, at negative 1, 0, and at positive 1, 0. What are the y-intercepts? That's going to be right here. So we would say at 0, 1. What is the absolute maximum? So that's the highest point the graph goes. So let me see if I can move this down a little bit. All right, so the absolute maximum is going to be that point right there. That's the highest it goes, and that y value is 3. So where it says what is the absolute maximum, we're going to say that's 3. What's the absolute minimum? This is the lowest point that we see in our graph, and so we're going to say that our absolute minimum is a negative 6. All right, our next question, let me scroll that down. It says, find the interval in which the function is increasing. So the function is increasing wherever, as you read the graph from left to right, where the y values are getting bigger. So that's going to happen right here and right here. So in those two places, that's where it's increasing. So the way I would write that, let me go back to that question down there. So the way I would write that would be from negative, oops, I'm in the wrong color. It would be from negative 2 to 0, and then union 2 to 4. That would be where the graph is increasing. Where it's decreasing would be where you see the graph going down as you read it left to right. So right here, it's going down as you read it left to right, and as you read this from left to right, it's going down. So we would write that as negative 5 to negative 2, union, and then 0 to positive 2. This is where it's decreasing. And I'm going to write again that it's increasing. It was increasing from negative 2 to 0, and then union from 2 to 4. That's where the graph was increasing, just so that you can see it with the actual graph this time. All right, the next question asks, what is the function, where is the function discontinuous? Well, the function is discontinuous at all the places that you have any of those discontinuities. So you see a discontinuity right here, and you see one right here. So we would say it's discontinuous at x equals negative 2. That is actually a removable discontinuity. And then we also have it discontinuous at positive 2. That would be a jump discontinuity. All right, and then it asks, what is the rate of change? So let me erase this. All right, it's asking what is the rate of change from negative 5 to negative 2. Well, that's this interval right here. So basically when it asks you what's the rate of change, it's asking you what's the slope. So the slope of this line is a negative 1. So on the interval, on the interval, negative 5 to negative 2, the rate of change is negative 1 because that's our slope. All right, and then it asks on the very last question, where is the rate of change 0? So the rate of change is going to be 0 anywhere it levels off. Like right here it levels off, and right here it levels off. And so those x values are right here at 0 and then right here at 3. So I'm going to scroll that down real quick. So where the rate of change is 0 would be at x equals 0 and at x equals 3. All right, so that's our notes for today. Thanks, y'all.